Hey, good morning, everybody. This is Mr. Ainsworth, and we're going to get into a discussion about how to solve and graph. Okay, I'm talking about solving and graphing compound inequalities. And you see the word compound? All that means is more than one, okay? More than one inequality at a time. We're going to take a look at two statements here. We're going to take a look at some or statements. We're also going to take a look at a few and statements here. They're completely different. And on the second side here, we're going to look at a different type of compound inequality like this right here. So we have a lot of work to do. Get out your red pens. I would get out 2 or 3 different colors because I'm going to color code my lesson here, and let's get started. All right, we're going to take the inequality here over to the right-hand side and work on it. X plus 2 is less than or equal to -4, or x divided by 3 is greater than 1. We're going to step this out. We're going to solve them first. Okay, you do that first, and the second thing, we graph them, okay? Now, let's always do the inverse here in algebra. By x plus 2 here, I need to cancel out the 2 and solve for x. So I'm going to subtract 2, inverse of adding. When I do that, the opposites cancel to 0 here, and I get x less than or equal to -6. -4 plus -2 is -6. When we graph that here, since -6 is less than or equal to -6, it's going to be closed here at -6, our reference point right there. We're going to close there, and all numbers less than that lie to the left. Okay, this is x less than or equal to -6. Graph in red, it pops out. Okay, we're going to do this in multiple colors. On the next inequality, x divided by 3 is greater than 1. We're going to do the inverse of dividing by 3, which is multiplying by 3. Simplify a little bit, and you get x greater than 3. Now, since 3 is not greater than 3, it's not a solution. Our reference point 3 here is not a solution, so we're going to go open. And all numbers greater than 3, like, well, that's not 3. Let me plot it correctly here. 3 is right here. There's a reference point. We're going to go open at 3. And 4, 5, 6, 7, 8, 9, 10, and so on are greater than 3. So we're going to graph to the right. So this is x greater than 3. So our solution set is two-part. X could be on this side, or x can be on this side here. It could be less than or equal to -6, or, put a big or here, or x could be greater than 3. It's two-part inequality. Now, number 2 is similar fashion here. And remember, this is a video here, so I'm going a little bit fast because I'm by myself. But remember, it's pause and play video. So if you need to listen to anything again, rewind it. Pause, catch up in your notes. Okay, pause and play. Let's take the next few inequalities here off to the right. So we can work on them. X divided by 5 plus 2 less than or equal to 1. Let's work on them. All right, the inverse of -2 is a +2. So you're going to see this in red. I always do my action in red. And I get x greater than 1. Okay. So this is an open circle at 1. There's my reference point right there. I'm going to go open at 1 and to the right because numbers like 2 on are greater than 1. On this one here, I want to subtract 2. Cancel out opposites here, and I get x greater than 5 is less than or equal to -1. All right, after multiplying by 5, because it's the inverse now, I get x is less than or equal to -5, which is between -4 and -6. Now it says less than or equal to, so it's closed here. All numbers less than that lie to the left, like they always do. All lesser numbers go left, all greater numbers go right. So just remember that, x less than or equal to -5. Notice that the arrow is also the same as inequality. They both point to the right. That's another clue too. It's a quick, easy way to remember how to graph the inequalities if you don't fully understand them. But again, we're trying to understand things. X greater than 1 means 2, 3, 4, 5, 6, and all the numbers to the right. So x can be here on the left of -6, or excuse me, -5, or to the right of 1. And -5 is the solution because it's closed. Okay, it could be equal to. Now, the next few inequalities are quite different. These cases here, the and cases, you got to interpret a little bit differently. So let's go through that. You got 3x plus 2 greater than -4. And now, all right, x must be, x divided by 2 plus 2 must be less than or equal to 3. Here, for the and statement, you got to satisfy both of the inequalities at the same time. So we're going to do this in multiple colors. Let's subtract 2 first and isolate x. Cancel out opposites. 3x is greater than -6 again. We're going to divide by 3 because that's the inverse. All right, it's 3 times x, so we want to divide by 3. Dividing is the inverse of multiplying. All right, simplify. You get x greater than -2. All right, when you graph this right here, open at -2, which is reference point to the right. On the next inequality, I want to subtract 2. And what do we get? Well, we get x greater than 2, x divided by 2, cancel out the opposites, less than or equal to 1. We have to times 2 on both sides to clear your fractions, and you've got x is less than or equal to 2. Now, let's put that in right. So x, here's your reference point 2. It's less than or equal to, so it's closed here. Go above it, and all numbers less than or equal to 2 go to the left. Let's write the word and here. When you have to satisfy, when you see an and statement, you have to satisfy both inequalities. Okay, satisfy, or let's say must satisfy both inequalities. Move this up so you can see it. And because of that, we're looking for the intersection. On an and statement, you want to look for the intersection or the overlap. So where do these two inequalities overlap? Well, it's right in through here, okay? In that region right through there. And so x must be greater than -2 and x must be less than 2. The only numbers that satisfy that are these numbers in through here in the overlap. So let me write that down here. This is the overlap, okay? Or the correct word is actually the intersection. So overlap or intersection is the solution set, because that only the overlap is where you satisfy both inequalities. So in blue now, my solution set is from -2 to +2, and all numbers in between, including 2, okay, but not -2 because it's open there. All right, this right here is my solution set. So you have to, I'm looking for that third piece here. The two pieces in red are just the two inequalities individually, but where do the numbers exist that satisfy both? Well, it's the intersection in that yellow area between -2 and 2 and including 2 because it's solid. All right, so you got to have that third piece right here. I'm looking for that. That's our solution set. Now, number 4 is a very similar thing, so let's go ahead and do it one more time so you can see the similarities. All right, so see the similarities here. Let's go ahead and take a look at both of them here. Okay, I'm just rewriting and doing all the action on the right like we always do in our notes, 2-column style. Okay, on this one here, we're going to add 5 first. And we're going to take 2x greater than or equal to 1 here, divide by 2, and you get x greater than or equal to 1/2. All right, now that's closed at 1/2, which is halfway between 0 and 1, right here, and to the right. Now the other one, we've got to subtract 2, and you've got 2/3 x less than 4. Now on this one here, I would definitely multiply by the reciprocal, like we handled it in the past. That's the fastest way you can cancel out a fraction using multiplication right now. So times by 2/3 times, 3/2 times by 3/2 here. Remember that the reciprocals, whenever you multiply them, you get 1. And so you get x less than 4 times 3 is 12. Divided by 2 is 6. Right, and you get x less than 6. So let's go ahead and graph that. So 6 is not a solution, so we're going to open a 6 and then to the left. Okay, now what do we have? So we're going to looking for where do we satisfy both? It's got to be greater than 1/2 and less than 6. Numbers like 0, or not 0. 0 is not greater than or equal to 1/2. Like 1. 1's greater than 1/2 but less than 6, and that's in here. In fact, let me put in blue here. 1's right about there. And 2 satisfies both of them. 2 is greater than 1/2 and less than 6. And 3 and 4 and 5. All right, but not 6. So we're going to go open at 6 and close at 1/2 and all points in between. All right, let me highlight it. This is the intersection. It's the overlap. So that third piece in blue right here, this one, that's my solution set. All right, it's all points from 1/2 to 6, including 1/2, and all points in between. So I'm looking for that third piece right here. You got to satisfy both, and that's always the intersection or the overlap. Now on the back side, number 5, these are also compound inequalities, but they're written in a little bit different way. It's actually 2 parts. We've got this part here. 2 is 2 is less than or equal to x, and the second part's right here, x is less than 6. And so what we're going to do is we're going to treat this inequality here the same way we did the previous one. But if you have to understand here, if 2 is less than or equal to x, that means that x is greater than or equal to 2. It's very similar to this, so I'm going to make something up. If 5 is less than 6, that means 6 is greater than 5. So if you switch the inequality right here, you got to switch not only the order, but the inequality itself. So if 2 is less than or equal to x, that means x is greater than or equal to 2, which means that, let me find 2, it's right here. I've got closed at 2, right here, and to the right. This one here, x is less than 6, that's this reference point. Okay, that's open at 6, and to the left, but where do they intersect? Well, because it's an and statement, right? They intersect right through here. So what I need to do is I need to graph that. So they intersect at 2, but not 6 because it's open there. So we're going to go closed at 2 all the way open at 6. This is my solution set in blue. So typically when I just do it here, I understand that what I mean is what this means is that it means all points between 2 and 6 basically, including 2 because the equal to part here. Once you get experience, you're going to go right to the solution set and bypass what you see in red. So for example, my 2 reference points are -1, which is right here. Let me put it in red. Right here, there's my first reference point. My second reference point is 7, which is right here. I see the x less than or equal to 7, so it's a solution. Since -1 is less than x, that means x is then -1, so it's not a solution, but it's going to be all points in between. Okay, x is between -1 and 7, but it includes 7 because of the equal to part. And that's usually how I approach it. I don't graph them both individually like I did. Let me go back up to number 5. Like I did individually here for the 2 parts and then go for the intersection. Once you're experienced, you understand that x must be between -1 and 7, all right, but including 7 because of the equal to part here. So we go closed. All right, so one more time, one last one here. We've got this inequality here. -2 is less than x divided by 2 plus 3 is less than or equal to 6. All right, and to handle this one here, this is a unique way to do it. We got 3 basic parts, okay? You've got the left here, -2, and then you got this middle portion, and then you got the right side. So really in this compound inequality, you got 3 parts. So whatever you do to one part, you do to all parts. And I want to solve for x here, so what I'm going to do is I'm going to subtract 3 on all parts. This is the fastest way you can do this. All right, you're going to cancel out the opposites here. -2 and -3 is -5. That's less than x divided by 2. Remember, this cancels out to 0 now. All right, less than or equal to 3. And I'm still not done yet. I want to solve for x here, and right now it's being divided by 2. So I do the inverse. I multiply everything by 2. So times 2 here, times 2 here, times 2 here. I get -10 less than x, which is less than or equal to 6. Okay. So right here I see a less than, strictly less than, so it's going to be open here at -10. I see right here the less than or equal to, so I know it's going to be closed here at 6. So what I do is I go up to the graph and I find -10, I go open here, I go closed at 6, and I know it's all points in between because I understand this now. And so this is my solution set. It's all points between -10 and 6 and including 6. All points, all right, between -10 and 6, including 6. And I say including, and that's why it's closed here at 6, but not including -10 because it has to be strictly less than. All right, so x can be any one of these points in this region. There's other ways to do it, but that's the easiest one. We'll practice that in class. And this is Mr. Ainsworth. Remember, this is a video, and so you can pause and play throughout it. If you want to rewind the video and listen to anything again, be my pleasure. All right, and I'll see you in my next lesson later on. Bye-bye.